was working. Hey, there I am. Hey, it's me, John Park, and welcome to John Park's Product Pick of the Week, JP's Product Pick of the Week, or JP Papow, as I sometimes call it, to myself mostly. So, first of all, I want to say, head here, go to this URL, go to this QR code, point your phone or whatever, camera of some kind, at that QR code, because you want to head to the product page for today's product pick of the week so that you can take advantage of an insane, outrageous 50% off discount that we have only right now during the live stream. So go there. That's where you want to watch this thing. We've got this YouTube video playing right inside of there, or at least keep an eyeball on it if you want to watch on Twitch or Facebook or one of our other many fine video streaming partners. So I'm going to mix things up a little bit, and I'm going to head over to the mystery cabinet to grab this product right now. Yeah, right, so there it is. That is the product of the week. It's our BME680, not to be confused with some other similarly named sensors. And what is this thing? So this is an environmental sensor. There's a little picture of it right there, the BME680, and it is everything that some of the other sensors we've looked at is in this Bosch line and more. So this is a pressure sensor, a humidity sensor, a temperature sensor, but then it also adds a easy for me to see, VOC, volatile, there we go, volatile organic compound sensor, VOC sensor, and we'll talk about that one in particular today, as well as CO2, and those can be synthesized into air quality. So that little tiny, point that at there, the little tiny silver package in the middle there, that does all of those things. It senses all of those things. And we'll talk about that a little bit. Before I jump into it, I'm going to have a little look at the origins of this sensor, and we'll have Lady Ada talk about it, and then we'll see the evolution from November 2017 to today. This sensor has been in our lineup for a while. It's been pretty popular, and now we have this STEMMA QT version. And if you didn't know, STEMMA QT is our modular system of connecting sensors to microcontrollers that uses a little tiny 4-pin connector, JSTSH connector for I2C. We also have STEMMA, which are full-sized ones in both 3-pin and 4-pin varieties. So there are over 50 of these in our lineup now, just sensors alone, and then we have relays and displays and all sorts of other things in this, and I've been really loving it. It is compatible with and based on the quick format from SparkFun. The small ones are, and then the larger ones are more similar to the Grove standard from Seed. So this is one of these. This is one of these STEMMA QT boards. So I'm going to have Lady Ada take it away right now, and we'll go back in time a little bit, and we will fix my audio for a second. There we go. I think I had my gain up a little hot from something I was doing the other day with a different microphone. My bad. That should be better now. All right, take it away, Lady Ada.
The BME680. I've been working on this breakout for like 2 years. I had samples a very, very long time ago, and we had this breakout, and finally we had chips came in, and so we're able to make the breakout and get it in the store. The BME680 is kind of nice if people have used the BMP280, which is a temperature and pressure sensor, or the BME280, which is environmental, has humidity, pressure, and temperature. So you can do altitude or barometric pressure, humidity, temperature, so all that good stuff. But the BME680 adds a MOX sensor, a metal oxide sensor, and these are sensors that are it's a metal oxide, and you basically put, you heat it up and you measure the current through it, and as there's more volatile organic gases in the environment, the resistance goes down, which makes these really good for measuring like alcohols or carbon monoxide. They can measure ethanol and a couple other different gases, basically any of the gases that react with the metal oxide layer. The thing about the metal oxide sensors is, they take a while to heat up, so you have to have it sort of sit for half an hour, and you get a resistance. So, the gas sensor here is 275 kiloohms, and then, if I breathe on it even, it should go down. Now it's 218 kiloohms. So part of that is humidity, and part of that is, I just drank some fluid and ate some food, and so I have some probably gases in my mouth, and also carbon dioxide's coming out of me because I am not a robot. I'm a living human being.
You're real.
You can't prove that I'm a robot. Yeah. And so, you have to do a little bit of calibration and math with these gas sensors, but it does work quite well, and what's nice is it's an all-in-one sensor. So this is kind of like the most integrated environmental sensor we have. It's pretty sweet. There is a library that Bosch has that can give you air quality out, but it's like a very close source and compiled binary only. So we're kind of looking at some solutions for that. For now, we just suggest looking at the resistance and the humidity and just plotting those and take the baseline reading of the gas sensor and then using that to determine whether you're getting more or less contamination in the air.
Next up.
Okay, next up, we've got the BME680. This is a sensor that we've had in stock for a while. It has pressure, humidity, temperature, and gas sensing. We've revised this to now be STEMMA QT compatible. So you see it's got these nice plug-in cables that you can plug and play for I2T support. It's mechanically a little different looking, but it has the same pinout, same code, same software. So if you would like to add a quick plug-and-play sensor to any of our STEMMA QT capable boards, then this is an easy way to do it. It's got level shifting and everything, so you can use it with Arduino, Raspberry Pi, CircuitPython, whatever. Get environmental data super easy.
All right, yeah, thank you, Lady Ada, for that. So hopefully that gives you a little lay of the land on this board and on this sensor. And now what I wanted to do was show you a couple of demonstrations. So let's jump to my overhead cam here. What you'll see here is that I have a little QT Py plugged into power. This is running an Arduino sketch or Arduino code that's using this library from Bosch. So Lady Ada mentioned that there's this BSEC, B-S-E-C, Bosch something or other, environmental something or other. I like to call it BSEC, but that's not really it. It's BSEC. So this library, she actually has just added some code to a guide, and I'll point us at that in a minute. So you can run this using Arduino. And you can see here, I've got my BME680 plugged in over STEMMA QT, and I'm actually chaining it through this big, beautiful 1.3-inch OLED here that is displaying the code, and I have it flashing back and forth between two pages of data. And what you'll see here is that, as Lady Ada mentioned, you need to kind of warm these up. There's a little heating plate in there that gets the metal oxide sensor going. And so the burn-in time at first is about a half hour, but that's when you first get the sensor, first time you use it. Now it takes about 5 minutes. So do know that this is going to have dead steady readings at like 0.5. It just says 0.5 across the board for the gas sensing until it's gotten up and warmed up the metal oxide sensor. So now what you'll see is what I'll do is I'm going to take a little swab and I'm going to take some isopropyl alcohol. So I have my little bottle of isopropyl that I keep around. I think this is a 99% isopropyl. And as you probably know, this stuff is noxious, right? It's got a really strong odor, and that is, you'll see here, the VOC level on my display right now is 2. And just a moment of hovering over here with this swab, and it is pegged it at 1,000. That's actually the max value. So I'm going to take this away, and you'll see as the air clears in that area, and I can just fan my hand at it, After a few seconds, that will start to drop back down. I'm going to blow on it. As the air clears and the sensor kind of gets back to normal. You can see this one's a really strong one. I've tried other things and they don't kind of peg it up at the top for so long. And I'll let that cook. You can watch that, but that's going to take it a little while. There we go, 370. So now it's finally dropping back down to sort of normal air levels. And I believe that's parts per million is the value in that. And you can take a look in the data sheet and in our guide to learn a little bit more about that. And in fact, let me show you that right now. So I'm going to jump back over to the browser here, and you'll see, okay, so here is the product page. Hopefully you're watching that in there, and if I refresh this, I'll dare to refresh it, boom, this is half off, so $9.48 right now, instead of normally $18.95. Maximum is 10 of them, and don't resell them, but if you have a use in your life for a lot of VOC sensors or some of the other environmental sensing, this is a great time to get them. And now if we take a look at the guide, we've got all the info you need about setting it up, running it over either SPI, you can run it over SPI, or you can run it on I2C, which is what the STEMMA QT is using. And there are examples of using the code in CircuitPython as well as Arduino. Now, if you're going to use the, this is the new, I don't even know if this page is published, I might be looking at a sneak peek version of it, but this is this BSEC air quality library from Bosch that we've based a sketch around. So you can go here and load in that library from Bosch and this example code, and you'll be running essentially what I have on that OLED there, except for I've got bigger text just to make it easier for you to see. If you look at the product page from Bosch, there's the little sensor itself. Like I always want to do, what do they think you should be using this for? Here you go. Typical applications, indoor air quality, so that's this IAQ, indoor air quality. Home automation and control, Internet of Things, weather forecasting, enhancement of GPS, that's using the pressure sensing for altitude, indoor navigation, same sort of thing as we saw with the BMP680 previously, outdoor navigation, vertical velocity indication, and then some target devices that you can put it in, basically any device that's small. Now, speaking of running this in CircuitPython, what I'm going to do is switch over to this example here, and I'm going to move a little camera around, and give me a moment because this will require a little bit of a refocus. And let me give you that view nice and big, actually. So this is a little rig that I set up. It's also running a QT, and I'm chaining it into the I2C sensor of another of the BME680s. I also have some NeoPixels, a little NeoPixel ring there with a diffuser on it. Let me show you a demo of this and I'll show you the code. So here's a fun demo. I've got a couple of glasses of nondescript liquids. Oh, and you can see one of them is pretty noxious. It set off my sensor. So let's set the first one here. If we set this glass here, it is not responding. That's because this is some iced tea. If we take this other one, this is some Scotch whiskey. And you can see very quickly that resistance drops on the MOX sensor, telling us there's a lot of volatile organic compounds. And in fact, I poured this little shot of whiskey yesterday, and it's just been sitting out and hasn't really lost any potency. So it may have evaporated a little bit, but there's just tons and tons of these gases coming off of it. If we give that a second, it should, I'm going to blow on it, just because we don't have much airflow in here right now. And then you can see the other glass shows up as green instead of red. So let's take a look at that code that's running on there. So inside of CircuitPython here, I have, I'm running my Atom is the program I'm using. I'm running Atom, and this has a serial monitor in the bottom, which is convenient. You can do the same thing in Mu. This is the code that I'm running. And down here, we're seeing the resistance of the gas sensor. So unlike that previous demo in Arduino using the BSEC library, this is not synthesizing this into any particular units other than what's the resistance on the MOX plates. That's sort of the raw data. And so what you can see is I'm importing that library, BME680, as well as some other helper libraries, setting up I2C, setting up the sensor, setting a few color definitions for the pixels. And then here's where the magic happens. In my while true loop, I'm printing out the gas value in ohms, which is just simply asking sensor.gas, and it returns that value. And then I just through some experimentation checked out, okay, at what values does this start to get impacted by putting a VOC gas in front of it? And at that point, we drop to red. And if anything is over this 16,000 ohms, then we are going to go to green. So you can see here the resistance will drop again as I put my whiskey in front of there. Now we're down at 3,000 instead of what we were at, 60,000. And you can also do this with some other things. So for example, here's a couple magic markers. One is a big fat Sharpie. The other one is a kid-friendly Crayola. So check it out. I'll take the Crayola and hold that really close to the sensor there, holding it, waving it, nothing at all. You can see the values there are pretty high on the resistance. Now we'll take the big fat Sharpie, hold that up there, and boom, it has dropped down to, gosh, it's more potent than that whiskey, I think, 3,000, yeah, around the same range. So that's Sharpie versus kid-friendly. And you can do this with a lot of other substances. There's, as Lady Ada mentioned, you can check CO2, you can check breath detection. You could even sort of make your own version of a breathalyzer with this, although I wouldn't try to make it admissible in court. So let's see, that is the thrust of our pick of the week. It is this lovely little, I'm going to detach this one right now. There it is. Let me put it on a nice hanger. That's the pick of the week right there. This is the Bosch BME680 in STEMMA QT format. And I'm going to switch out my cameras here for a second. There we go. Remember, you can head here to this page, go to this URL, go to this QR code. That will take you to the product page. You can get it for half price right now. That's, what did we say? $8, $9.48 instead of $18.95. So a great deal right now, only during this show. So go buy. We want to see those products flying off the shelf because it helps keep Adafruit going. And that's important to us all, I think. All right, well, I think that covers everything I wanted to talk about today on our little sensor. So that's it. That is my product pick of the week. It's the BME680, and that is an environmental sensor that covers everything from temperature. There we go. It's the BME680 that covers all sorts of environmental sensing from temperature to humidity to pressure and all sorts of VOC gases and CO2 and even indoor air quality sensing. So that's my product pick of the week. I'm going to hang it up on my little pegboard of STEMMA QT goodness. And that is it for another episode of JP's product pick of the week. I hope you enjoyed it. I hope you go out and get yourself one, and we'd love to hear what you use yours in. Build a project with it. Tell us all about it. And don't forget to go and check out the guide for this, including all that new content that Lady Ada has just published with the Arduino sketch. All right, well, thank you so much. That's going to do it. I'm John Park, and this has been JP's product pick of the week. See you next time.